Alright, welcome back. Hope you're all well. Thanks for joining the channel. Good to see you again. So this is part 2 of the Rotel RX-1603 monster receiver. We're going to focus our attention on these two power amplifiers. Massive power amplifiers, they're bigger than my hand. And we have a central power board here in the center with our protect relays. Or no, actually it's got a soft start. And then there's a board back here with our speaker switch relays. We have our power supply section with the main filter caps. I took these out to test them. But first let's remove the power amplifiers, and we'll work over on both of these at the start here. So we have a lot of cleaning to do. There's a lot of filth in here, and we have a little bit of recapping. We have 4 caps on each power amplifier and a cap on this board. I think there's a couple caps on the back. Not too many. But we're going to clean all this up. We're going to start by removing the power amplifiers and work on them one at a time. And then we'll work on the rest of the chassis. So stay tuned. Alright, let's talk main filter caps. So this is a, let's see what's, oh, it doesn't really matter what size it is right now. This is a 80 volt, 22,000 microfarad Nippon Chemicon. It's a good quality cap, but it's 50 years old. Getting 50 years old, be 50 in another couple of years. So she's old and tired. Let's see how old and tired it is. Now before I ever measure one of these huge caps, I always check for voltage on them because they can present a voltage on their own just from sitting. So let's check this one, and this one's down 50 some millivolts, so we're okay. If it had a couple volts charge on it, I would just take something and short it out. If it had more than just a couple volts charge, I would get a resistor, because you don't want to short out a capacitor of this size with any appreciable energy stored in it, because it'll create a big bang. So we have the thing discharged now. I think I discharged it. Okay. Let's try this out on my machine, see what it says. Let's connect it like that. No, that's not working because I'm not getting the milliohms properly. Okay, there we go. So you can see 15,000 microfarads and change, and we got about 4950 milliohms of ESR. It's supposed to be 22, so they're down quite a bit. I didn't pull up the other one and check the other one too. Let me do that. Okay, let's check for a charge. And what do we got here? 5 volts, 4.5 volts. Should be okay to discharge this. The screwdriver kind of got welded to it a bit. A little bit of a spark. Okay, see how it charges up after you release the short circuit? Oh, you can see that. See, it's 0, let go, and it floats back up. That's dielectric absorption of the capacitor, and that's does that naturally, so you got to be aware of that all the time. Even on small caps they do that. So let's connect this up and let's see what we got. Oh, this one's even worse. Oh, maybe not. This one's about the same. It's got a lower ESR by about half the ESR of the other one, but it's still around 15 and change. So I'm going to suggest to the owner that we replace these two. I did have a look on DigiKey, and they have, what is it, 36,000 microfarad, same can size, a little shorter, not as tall, same diameter, screw terminals, should drop right in, and we get a little boost of capacitance. That's jumping up in capacitance at this point is no problem because we have a soft start circuit, and it shouldn't pose any problem with these caps charging up. And if it does pose a problem, we can make adjustments to the soft start circuit. We can fiddle with the resistor value, and we can go that way. But we'll see what we can do. I'm going to talk to the owner about replacing these two caps. These two caps are actually fine. They will work in the circuit, but they're 50 years old. They're down on capacitance already. So we have the opportunity now. Let's change them, and then we get some fresh caps in there. And these will last maybe another 10 years, 15 years before they completely fail. but let's not chance that. So it is going to be a little expensive. I found caps, there's about $65 a piece Canadian, be about 40 some dollars US, but I think it's going to be worth it for this part of the restoration, just to get these out of here and put some new ones in. These test out at 15,000 microfarad. What we've done is we have ordered new ones. So I've managed to source new ones. These are Chemet's 36,000 microfarad 100 volts. Now they're the same physical diameter, a little shorter as you can see, so that will work out just right in this application. And these ones are nearly 50 years old, so 2324 date code, so it's all good. So somebody's been in here working on this thing, because these are not factory joints. Somebody's had these wires off. I don't know if you can see it, but if you look at the factory solder, there's a little bit of red, looks like red felt marker that they used to touch every joint to make sure it was done, and these ones don't have it. So somebody's had the power wires. These are, looks like this is our plus and minus rails, plus a speaker output on that side, and then on this side, this side looks all factory. Looks like it has been touched. Or maybe it has. It's hard to tell. I don't think it has. But then somebody's been desoldering these two wires too. Look, they don't look too good. And that is a brown wire. Where does the brown wires go? That goes to the mains power outlet. So this is part of the soft start circuit with the resistors here down below. Can't see because yeah, these two wires are part of the soft start circuit. There's the resistors for, there's a fuse, and there's a relay down below here. So pretty much what I'm going to do is I'm just going to gut everything except for the transformer. It can stay on the chassis. Remove the both power amplifiers, remove the rectifier board, fuse board, and the soft start, and then I'll remove the speaker outputs along with the relay board on the back here. I'll just remove it all because it's all going to get put into the ultrasonic. It's pretty filthy. Everything's pretty filthy in here. So it's all going to get put in the ultrasonic except for the transformer and the new filter caps, obviously. But everything else is going to get gutted so I can get in here and clean everything. Yeah, these power amplifiers are pretty dirty. A lot of dust gets in between the fins, and I want to make sure all that's spotless before it goes back together. And then as I pull out the amplifiers, I'll deal with the boards recapping and any modifications I'm going to do. And then we'll get started with that, I guess, and see how that goes. So just doing disassembly here. I got the power amplifiers off, removed, desoldered, and disconnected. So I was taking off this false bottom just because it's dirty and it needs cleaning. Look at the size of that mosquito. It's like a small bird. We don't have them that big out here. We have little tiny ones. This is one of the big fat dumb ones. They're pretty slow, but the little ones, they're fast and they get you. But yeah, I gotta clean this all up. Look at the corrosion in there. And yeah, it's just a false bottom. There's nothing in here but accumulated for dirt. Okay, those with a weak stomach might want to look away, but I just want to give, this is what I got it reduced to, just a bunch of cut wires. Now seriously, what I do is I photograph all the connections on all of the boards, the colors of the wires, where they go, have photographs of all that, and then I go through and I start desoldering these thick wires. For example, these are the transformer secondary windings, and I'll desolder these and take them out of the way. Do the same on this side. And for these little wires, what I did is I did a combination of, what I do is I just snip them off, and I leave a little bit of the color there, about a 1/4 inch or so, and I know where that wire goes because it's been cut from that area. Now here I had 2 brown wires, for example, and I had 2 red wires. So what I did is I cut one of the red wires and I desoldered the other red wire. And I did the same for the brown. I desoldered one and I cut the other so I can tell which one goes where. And then everything is disconnected. This can come out. This is the main power rectifier board and a soft start. And it's pretty filthy. It's going to go in the ultrasonic. That's why I wanted to get it out. Look at this side. It doesn't look good at all. Looks like somebody's been playing around here. I don't know. That can't be factory, is it? It's just a mess. Anyways. And then I removed the speaker selector relays and that board and all of the speaker outputs. Same thing. Leaving all the wires attached on this one. I found another relay underneath I didn't know was there. And this, I think this is the protect relay. This is the main protect relay, and then these are the 3 speaker relays for the 3 outputs. There's 3 outputs here. And there's another reed relay here, and a couple caps and so on. So we'll get all this dumped in an ultrasonic 2. This is all disconnected and can go. And then I have a bare chassis pretty much I can clean and get this all looking good. It's filthy. It's got like dead bugs and grime. Yeah, this will clean up nice. Alright, so here's the rectifier board. I'm just going to take off these brackets. I don't know why they had these little wires here. Both of the top screws had them, and something to do with assembly maybe. They had a little wire there and then they snipped it off after. See, there's another one. Don't know what that is all about. We'll get rid of these brackets for now because they're kind of makes things awkward. Okay. Alright. Now, my plan is I'm going to remove the relay, remove the heatsink, because heatsink has to be reapplied with paste. It's all dried up. Yeah, actually it's not bad. Well, yeah, we're going to redo it anyway. Get rid of that. These fuses, I don't even know if these are the proper fuses. These look like automotive fuses. They are 10 amp, but they have no 10 amp, but they have no voltage rating. They should have a 125 volt rating, and that looks like an automotive fuse the way they stamp them like that. I don't think these are the right fuses. This is a 3 amp here. This one looks correct. 3 amp. There's no voltage rating on them. And these 10 amp fuses. Bus AGC 15. 15 amps? Is that what that is? 32 volt. Yeah, these are automotive fuses. That's those are garbage. There's a 15 amp fuse in there. What's this one? Doesn't even say. Oh, 20 amp. There we go. 20 amp at 32 volts. Wrong fuse. Fail. Okay, so we'll get this dumped in the ultrasonic. And I'll get to take the relay off first. So let's have a look at this. We have a soft start circuit here on these two. These two here are mains voltage. Comes in, goes to a fuse, 10 amp fuse, okay? And then it goes to the relay contacts, and then it goes to the resistor bank. 2 resistors, looks like it is, I can't really read them. Let's loosen this off. Looks like 200 ohms to me, but I just want to make sure they're both the same. Okay. Stuck. I'll have to undo the other screw. But goes through the 2 resistors, comes back out here, goes through this thermal cutout or thermal fuse that's attached to the resistors. Okay, and then it comes back here, goes to the relay contacts, and then goes out. So when the contacts are open, the current flow is through here, through the fuse, through the resistors, back out. And then when the relay closes, it comes from here, through the fuse, through the relay contacts, and out. And then these two resistors are bypassed. It's a pretty simple circuit. I don't know what controls it. I think, yeah, this little circuit here controls it. And that's just a little transistor switch. When the voltage gets up to a certain point, it turns on the relay, and Bob's your uncle. 133 microfarad cap here. I don't know if they've got a little power supply for something. There's a little diode in the cap, and dropping resistor 1K. Don't know what that's all about. Okay, so replace that cap, yank that relay. Don't get in the ultrasonic, make sure it's clean. We're going to clean up this mess. It's pretty gross. I don't know. Is that hand soldered at the factory? It must be. It is hand soldered, but it sure looks like a mess. Looks like somebody was having troubles with not enough heat. So we'll fix that all up. Alright, so after 20 minutes in the ultrasonic, all this stuff came clean. This turned out pretty good. I don't know. Looks pretty good to me, except the back. Don't ignore the back, that's going to get cleaned again. But that's looking good. So I removed the 5 relays off here. There's 5 relays up here, and that's all on these 2 boards. And this is going in next. I'm going to dump it in as a unit. Wires and all, connectors and all. And we're just going to clean the snot out of this thing, because it's got grime baked into it everywhere. I was looking at this. Look at this heat sink. Look what it did. The ultrasonic cleaner did to my aluminum here. It actually went and pitted into the metal that was sitting on the grate, the screen, whatever it is, the cage, the basket. That's what it's called. It was sitting on the basket, and wherever it was touching, it etched into the aluminum. And if you look at it, it's got big pits in it. So that's pretty hostile towards aluminum. Even on this side there's pitting right here and here, and that didn't even touch anything. So you got to be careful when you put aluminum into ultrasonic. But everything else came out good, so I still think it's a good thing. Okay, so I'm going to put this in next, and then I can start assembly this one. I got the relay clean. I'm going to replace this cap. I got a couple stickers here for the these didn't survive too good because they were just paper. Alright, let's have a good look at this big lump. That is a lot of aluminum. It's got a lot of weight. There's 4 transistors. Okay. Actually, let's take this in first. Yeah, I want to clean all this. It's just, ooh, my goodness. That's not cool. Well, we're going to have to deal with that. And check all the other ones while I'm at it. I wonder if that was like that from the factory. Okay. Take these good covers off. These are packed with dust too. Hey? If you look at them from one way, they look kind of clean, but when you flip them around, see all the dust and dirt. You flip it around, it's black. And you flip it around, it's brown. So these go in the ultrasonic. Everything goes in the ultrasonic. So take these out. And what do we got for silicon? Hey, we got 4 NPN transistors, so this thing's quasi-complementary. Didn't know that. That is incredible for a big amp like this to be quasi-complementary. Yeah, I guess it's early technology, I guess. Alright. Maybe what I want to do is I want to mark the position of all these transistors, where they go, so they can go back. I don't know if it makes a real difference or not. I don't know if they're sorted according to gain or matched or what's going on here. Yeah, maybe when I pull them out, I'll test gain on each one, and we'll see if they're matched. If they're not, it doesn't really matter, I guess. But my main goal is to get everything off so I can clean this heatsink. It's just filthy with dust and grime and everything. And then we're going to obviously service the printed circuit board, new caps. And this is kind of interesting here. We've got emitter resistors. They doubled them up. They use 1 ohm emitter resistors. See, I have a schematic here. I have to look at this. I can't really read. These must be it there. No, that's not it. See, this schematic is not great for reading because I can't read any values. It's just too blocky. But 4.7, 4.7. 1, 1. Interesting. Anyways, I'll get this disassembled. Let's get this thing off of this backing plate. Good. Have a look at this. I think it's Vaseline. I don't know, it's some kind of a grease. Vaseline has kind of a distinctive smell. I don't know. I can't remember, but wow, I got a little carried away. Alright, get yourself some blaster. Maybe I'll get a sponsorship deal out of this. Brake cleaner. Let's give it a squirt. And give these between the grooves too, good clean. Okay, let's give it a rinse. And then Alright, been busy working on these assemblies. This one here is all ready to go back in. I finished this one. So what we did here is we replaced 5 transistors. These the originals were 2SC1318 and they're on my list. So I took them all out, there's 5 of them, and replaced them with 2SC2383s. A little more robust transistor. Not that it matters. These transistors were only doing the duty of switching relays on and off. That's all they were doing. This is the overload protect relay, and this relay has gold plated silver contacts, which cleaned up very nicely, so that went back in. And these 3 relays here are speaker select relays, and they have gold plated silver contacts as well, and they cleaned up as well too. I swapped around their positions so that the best relay is on A now, and the other two have been cleaned. Replaced a couple caps. These ones are two 220 microfarad back to back to create a non-polarized cap, and so I just replaced in kind. Cleaned everything in the ultrasonic. Cleaned the board. These speaker connectors, they came out looking really nice. They look like brand new. So that's all done. Anything else on here? I don't think so. Resistors all checked out. The only thing I really did here was clean contacts and replace transistors in caps. So that can go aside. That's ready to go back in. Next up, we're going to start on these power amplifiers. And these were in the ultrasonic too, but they didn't come very clean. A lot of dust on them. But this is going to be recapped. And I also have transistors here that need to be changed out. These are 2SA750s in the long tail pair. I have a pair of them, so I'm going to have to find a pair of those, probably match them up. And then I have another one here, so 3 on each amplifier board. And the rest of this is pretty straightforward. Not much going on with these. A lot of butchered up solder on the back. Which one is this one? This one is the one with the broken socket. See this socket? What happened is this little corner broke off, and that allowed the connector to get pushed out. See, when you put a transistor in, there's no way to see this because it's all enclosed inside. So when they push the transistor in, oh, this is tough. Why isn't it going? It came out the back. This pushed out. So I have a feeling this is a base connection. I have a feeling this transistor that was in this socket wasn't even being turned on because this base connection was probably loose or disconnected. So yeah, I'm gonna have to replace this socket. Now I was watching a YouTuber, Novalux. He was doing one of these Rotel receivers, and he says he had problems on the testing phase. He had an oscillation that he traced back to these transistor sockets. I can't see how that's possible, but if I have to, I'll order up 8 new sockets and put them in. But as far as right now, I'm just going to replace the one bad one, and we'll see how it goes on the testing phase of things. If we have no problems, we have no problems. We'll let it go. Right now, it's just replace caps, and I'll get those 3 transistors, and then we'll see how it turns out. It's pretty much all there is to do to this thing, is replace caps and those few transistors. I did notice there was a missing capacitor here on this transistor 2. No, this is transistor, I don't know what number it is. There's a little ceramic disc on the back side of it, 15 picofarad. On the other channel, this is the one that had some work done on it. On the right here, that little capacitor is missing. Somebody took it out, and I can see where they did the soldering to do that. And somebody's also been doing other things on here too. Like some of these transistors. Some of these transistors have been removed and put back in because you can see the mess around here. And this one's no longer bonded to the heatsink. So somebody's been working on this. I don't know what they've been doing. Maybe the channel blew up and it was in for service. This one here had all the extra grease on the T03 transistors. So somebody was definitely on there playing around with this channel. Don't know what they did or what they replaced, but it all looks like original parts to me. But we'll get it more into this when I get it onto this one. Alright, so what does $20 buy me from DigiKey for silicone adhesive? This is a neutral cure silicone adhesive. I just bought it because I was running low. I was using the hardware store stuff, and I don't think that's the proper stuff to be using. Look at the packaging they needed for this. Anyways, this is a quick check. Yeah, sorry. So this is a chip quick. I don't know who makes this stuff. It's probably rebranded from somebody else. But this is a neutral cure silicone NCS 10G, $20 Canadian a tube. So we're going to try this stuff out and see. This is gray, and I got a use for it too, for anchoring large parts, like for anchoring these large parts that are flopping in the wind. I want to just use a little bit of silicone just to anchor them so that they're not moving around. You shouldn't have electronics with parts flopping like this, for the most part. Big heavy parts will eventually either break the pad, or break the pad from the board, or break the joint, or break the wire. So let's try this stuff out. I guess we can just cut this tip off. Now this is neutral cure, which means it shouldn't have any odors, or very little odors. Let's see. Let's cut off a little bit here. Put this on. I wish they gave you another cap that you could screw on after you remove the nozzle, because this thing eventually it cures and it sets up and it cures and cures and cures. And if you don't get to it before the next time you want to use it, it could be just a cured up lump of. So let's cut off. Oh, it's already open, so we don't need to cut anything off. So let's just use it. And get the gun. Okay, I think the first little bit will be just trash, so let's just get rid of the first little bit here. Okay, no, that's actually pretty good. So what I want to do is just put a blob in between these four, just to anchor those four together. And then we'll put a blob here. Let's anchor those four together. And I want to anchor this big resistor, so I'll tack it to this capacitor here. I don't want to put too much so that it's a rigid connection. And then we'll put a little bit to this capacitor. And once this sets up, once this sets up, it will be a nice solid bead. So let that cure. This one's done, pretty much. Here's the before and after. So we haven't got to this one yet. But things I did, placed the 4 caps. Electrolytics. I put 3 new trim pots. Tested all of the resistors for value. I replaced 3 transistors, 1 here, 2 here, and what else did I do? I think that's it for now. And then I cleaned the back of the board. I still have to clean because it's still dirty. But put this one aside, let that cure for 24 hours, and then we'll get started on this one. We got caps, transistors, and trim pots to change. And we'll clean up this mess. And yeah, I can't smell anything from this stuff. It doesn't stink at all. You know how regular silicone has that vinegar smell? And this doesn't. So, good. Okay, just a little update here. I'm working on the second power amplifier board, and I removed the driver transistors just because of this mess. It was dried up grease. Somebody took this apart, put it back together again, and you reused the old dried up grease. The one transistor wasn't even making contact. I did find a bad resistor here. This 100 ohm 1 watt tested out at about 85 ohms, so I replaced that one. That was the only one that was out of tolerance that I found on this board, and the rest of it was good. Somebody's gone through here and replaced probably half the emitter resistors. They've had these two transistors out for whatever reason, because they tacked on a third leg in the middle. It was cut short, and then they soldered a piece of wire on for that one. Where's the other one? Did I lose it already? Oh, here it is. Same thing for this one. It was too short, so they extended it with a little piece of wire, and then they got the dried up grease in the back. I'm going to put this all together, and I found a little clamp that I can use for clamping down this middle transistor. It's a bias temperature tracker or whatever, and it goes face down like that. And I drilled a little hole, and I'm going to use this clamp just to clamp that to the heatsink, and that'll be the end of that. And I'll put everything back together, and then pretty much it. The only thing I didn't investigate is this missing capacitor here on this one transistor. It's supposed to be, it was a 15 picofarad on the other board, but this one's missing, so I don't know what that's all about. And then everything's done except for the cleaning part, which I'll get it to. And then we can start assembly. I've decided to stick with this socket, and what I'm going to do is I'm going to put it together, then I'm going to glue it with resin just to hold it. There's nothing really wrong with the socket. The socket works. It's just that the plastic's broken on that one corner. So first I just want to clean it with alcohol, and we'll get a clean surface where the resin can bond to. Okay, dry that off. Just going to push this home. I don't think this was making contact when it came from the factory. I think it broke when somebody shoved the transistor in. There we go. Okay, that's home. No, it's not home. There, that's home. Just put a bit on the outside here and just zap it to hold it. And then we'll go with that. That'll work just fine. Alright, so I got this all cleaned up. I had to clean the base because it was quite dirty in here. Inside and outside, everything's clean, ready to start assembly. Now I'm just going to put this rat's nest together today. It's probably going to be my job today, is just put it all back together, wire it, and we'll save testing for probably another day. But today I'll have my calendar full here with just putting it back together, putting all the wires back where they belong, resoldering everything, and just double checking my work, making sure I don't miss anything. There's lots going on here. So okay, so let's get started. Alright, there it is, all back together. Other things to note, the fasteners they use are all machine thread screws. All these little black screws, they're all machine thread. And they don't work very well when they punch a hole through sheet metal and then they thread it for the M3 threads, and then they put the screw in. It doesn't hold very well. And if you're very not being careful, you can actually strip a lot of these screws. And I actually did strip a few screws here. And what you do is you just back them up with an M3 nut, and that holds it. But aluminum and machine threads don't really mix, not too well anyway. That was my only complaint about working on this. Was the hardware wasn't very good. Other than that, everything fell right back into position. The wiring harnesses all just kind of lay where they naturally go, so that's good. But I just want to check one thing before we continue on here. I want to check for any shorts on the output devices. I know I checked one of the amplifiers for sure when it was out of the chassis, but the other one I forgot. So let's check this one. That one's good. I'm just touching the collector of the transistor, and there's no shorts. So if I touch the chassis, I get a beep. Let's try this side. Okay, well, we got a short here, and it's a 0 ohm short on these two transistors. And the collector of these two transistors are wired together, so that explains why they're both. So on one of these two transistors I have a short, so I'm going to pull these two out and really have a close look at why it's shorted. It shouldn't be. It's pretty careful when I assembled it, but for whatever reason there's something wrong. So it's a good thing I didn't plug it in yet. So let me fix this. I'll pull one transistor out at a time and see if the short goes away, and then I'll try and figure out what's going on with that particular transistor. Okay, let me move the camera around. Alright, so I pulled the screws out of the bottom one. Let's check if our continuity's gone away. It's gone away off this one, but this is the shorted transistor. Okay, so let's pull these screws out. Okay, let's try one more time. Okay, so for whatever reason, the collector seems to be in the wiring, not the transistors. The collector still has a short. We have to investigate that, figure out what's going on. I don't think the transistors are shorted to the heatsink. Well, maybe this one is. Maybe that's the one. Okay. Let's pull this one out completely. It's going to be messy. Yuck. Okay. Let's see if anything changed. No, it's still there. Let's pull this one out too. Our short is still there. Where is it? No, our short is gone. Short is gone. I don't know if you can see that. So we're reading between the collector, which is probably one of the rail voltages, and ground. And that seems okay now. Alright, so I'm going to clean this all up and we'll put it back together and see if our short goes away. Okay, I think I sorted out the problem. I think it's just the transistor was maybe twisted a bit. It wasn't quite positioned properly when I tightened it down. But here we got nothing now. And then I'm going to tighten these down, torque them. Because I haven't done that yet. See how it moved? I have to do that a little more careful. Hang on, center this. It's kind of floating on a bed of grease right now, that's why it's okay. Already wants to move. Be very careful here when I tighten this down. Keep checking as I go. Alright, let's do this one. That one's already tight. Okay. Tighten this one some more. Check one more time. It's got to be good or else it's going to blow up, right? Now we got it good. Let's torque these finally. Give them their final torque. You've got to remember that the voltage rails are plus minus probably around 75 volts. So that insulator on that transistor has to hold back 75 volts of volt potential. So it's working now. Okay. Glad I caught that. Okay, what I'd like to do now is I'd like to set up the DC balance adjustments for both amps and the idling current. But I think what I'm going to do is I'm going to disable 1 amp here. I'm just going to remove the power wires for this amplifier. And we're going to tie them back so that this amplifier is dead. And we'll do one at a time. Or we'll do one, then we'll bring the other one online again. We'll take this off as their negative. And this one's our positive. Take these off. Power wires, I'll tape these up. Let's see here, I'll tape them up so they don't touch. Okay, I'm just going to quickly tape these up so that they can't short. Got 150 volts between these two wires, so we don't want them touching each other or anything else. So let's just put that there. Okay, so this amplifier is dead. This one's alive. Let's connect our meter. We're going to do zero balance first. So let's go to volts. Let's set this up. Can you see that? No, you can't. There, you can see that a little better, I guess. We're going to connect the voltmeter across the speaker output and ground. We already got half a volt here. No power has ever been applied yet. Okay. So we're going to turn it on for the first time. Let's plug this in. Plugging it in. Go live. I don't know if you can see that. Adjust this down a bit so you can see it. Alright, to turn it on, we need to plug this one into this one. So let's do it. It shot up. I didn't hear the relay click. That's no good, because eventually those resistors will overheat. Yeah, it seems like we got a problem already. Oh boy. Let me check for voltages here. 7.5, 60 volts. So something's dragging down our negative. 6 point something. Okay, let's plug it in and see if we can get a DC balance out of this. We're measuring 1.2 volts already. Here we go. Live in the hole. Is it going to fly or fry? It's frying. We got 60 volts on the output. That's not cool. Let me see something here. Check some of these voltages. Okay, 60 on there. 60 on there. Something's not playing nice here. We've got 70 volts on the output and climbing. Base. $69 volts on that base. 69 volts on that base. I'm wondering if this resistor here is RX-1603. I never checked this one. RX-1603. Where the hell is RX-1603? Right here? 100 ohms? That one might be open. Let me check. Not plugged in. Check and see if we have any voltage across one of these resistors. I've got these stupid fiberglass sleeves and all the leads, and you can't get in here to measure anything. I'm going to do some more investigation here. For whatever reason, we have 70 volts on this here, which tells me that we have a break here somewhere. I have a feeling it's that. 2 watt 50 ohms, but yeah, let me keep poking around here. Okay, so I seemed to figure out what was going on here, and it was my cock up. I had made a mistake. Now, what was happening was I was powering up this amplifier, and the output would ramp up to rail voltage, 72 volts or whatever, on the output, speaker output, and it would stay there. And I couldn't figure out why it was doing that. And I checked all the parts, everything's fine. Pulled transistors out, tested them, they're all 100%. Everything was good. And then I started probing around the input section, and I noticed the amplifier was working, but it wanted to clip right away. It would either go high and clip on the positive rail, or it would go low and clip on the negative rail. And that clued in my little light bulb in my head. And what it was is the input was ungrounded and it was floating. That was what was throwing me off. So what I did is I grounded the input, and bang, it's right away, it's good. Let me check my connections first. Okay, so let's plug it in, and you'll see it ramp up in wattage and then come back down again. And I'm scoping the output, and the output went high and low and then down again. So without the amplifier turned on, I was drawing about 3 watts when it was plugged in, and now that the amplifier is live and ticking, it's around 15 watts. And that is good. That's about 10 watts of quiescent current. So that needs to be adjusted. But I can put this all back together now and do the adjustment, knowing that I have to ground the input to get the amplifier to work properly, because I don't have any ground reference on these pins. They're disconnected, remember? So wasted a bit of time with that. So I'm going to put this all back together, and then we're going to continue on with our adjustments, our zero balance and bias, and we'll do that next. Alright, so let's do DC balance here. So I got it all wired in. I have my voltmeter across the speaker output and star ground and the capacitors. Everything's ready to go, I believe. So let's power this up, and you'll see the voltage spike. See, it spikes up at 72 volts. This power consumption goes down to about 3 watts. Okay, and then when I ground the input, drops to 0, and then the amplifier comes online, starts consuming current. So we have about 10 millivolts. It's not bad, considering I didn't pre-adjust the pots. Just turn this down a little bit. Seems to want to climb up. I'm negative right now. Let's turn this. Turn this into positive territory. Okay. Three millivolts. Turn down a bit. Oh, we're still negative. Now you got to remember, the soft start circuit is not kicking in, and we're still running on the 2 resistors here. So I can't leave this plugged in for too long. So I am going to quickly check bias. Let me reconfigure here. Let's go here and go here. And what do we got? 21 millivolts. Should be 30. Let's turn this up a little bit. Wrong way. Okay, I'm going to leave it low just because we don't have full line voltage on the transformer yet. So I'm going to shut this down. Shut this down, and I'm going to clip a 1K resistor across the filter caps. There's 150 volts here. Just want to clip this on and discharge these caps before I connect up that. This go. Alright, so the other amplifier is connected now, and I have the input grounded again. We need to remove our bleed resistor off the caps, and then we can plug it in Let's turn on our meter and we'll see what kind of spark shall we get here. Okay, we can't dilly-dally and take too long here because we're drawing a fair amount of power through those resistors. I'm worried about them heating up. You know what? I'm going to leave that for now. That's only 7 millivolts on the output. Let's check the bias quickly and then we'll shut this down. So I'm going to go between here and here, test point 1 and the negative rail. And we got 36. So let's turn this one down a little. Turn this one down to about 27 as well. Okay, I'll leave it there. Leave it there, and we'll leave this for now. This is just a rough alignment for the amplifier. Until the soft start starts kicking in and bypassing that resistor, we're going to have to take it as it is. So until that starts, the soft start relay starts kicking in and bypassing that resistor, that load resistor, I just wanted to get this roughed in close to where it should be. And now I know that we can connect it up to the other half and be close, fairly close. Alright, so that's it for this one. Let's remove this ground wire and let me reinstall the bleed resistor. Let that bleed down. Alright, this is as far as I'm going to take it this week. I think we did quite a bit here. Well, we basically just tore it down to nothing and rebuilt it. Replaced both cans. They were getting tired. These are replaced. Replaced dodgy fuses. Somebody was putting 20 amp automotive fuses in where they should have been 10 amp, rated for 125 volts. So those are fixed. Replaced 11 transistors that were on my naughty list. These all test out fine though, and I don't think they would have been a problem in the future, but I replaced them anyways just in case. We have one out of tolerance resistor, and I had one damaged mica insulator, and I replaced all 6 trim pots. I didn't even test these, I just replaced them. These are the open ones that I don't really have good luck with these. They're open to the elements and dirt gets in them, and so those are replaced and retired now. So next episode we're going to connect up the other half. We're going to marry it back together again, and then we're going to test all the functions. Still don't know if the soft start's working. I think it will once we connect it up with the other part here. It seems to be a lot of signals going back and forth. I don't really understand what's going on there. I didn't really pay attention to how it's wired. But everything's done here, and then everything's done on the head unit from the last episode. So we'll put them both together and we'll start testing, and we'll start doing alignments. Till then, take care, and we'll see you on the next one. Hope you stay well.